Okay, here's an example of the product rule. The product rule says if you have two functions named first and second, it's equal to the first times the derivative of the second plus the derivative of the first times the second. Or I like to think of it as fs prime plus f prime s. A lot of times I change these order. Usually I do the derivative of the first times the second plus the first times the derivative of the second. This is interchangeable, doesn't matter. Order doesn't really matter since it's addition. So we're going to do f prime of x. The derivative, this is our first function, and this is our second function. So I'm just going to do f prime s, fs prime, our first derivative of the first times second plus the first time derivative of the second. So therefore that is 3x squared, 2x squared plus x plus the first function, which in this case is f, so x cubed, times the derivative of the second, which is 4x plus 1. I'm now going to distribute this, so f prime of x, distribute this, gives me 6x to the fourth plus 3x cubed plus 4x to the fourth plus x cubed. And collecting like terms gives me 10x to the fourth plus 4x cubed, which is f prime of x. Note, if I rewrote f of x, so I'm just going to rewrite f of x again, excuse me. And if I distribute this, this is a side note here, we've already done the derivative of our function f. 2x to the fifth plus x to the fourth. And if I take the derivative, just using the power rule, I get 10x to the fourth plus 4x cubed. And look at that, same answer. So obviously it's much easier to do the derivative in this manner here, but this is the last time you'll have a product rule situation where you could actually multiply the two functions. A lot of times you'll have functions that cannot be quote-unquote multiplied, like sine times cosine. Take the derivative of that. Well, you can't just multiply sine times cosine and get something else. You'd have to use the product rule. So let's look at one more example, and we'll move on to something else. Just a little uglier function. So again, our product rule is the first derivative times the second plus the first times the derivative of the second. So therefore, I'm just going to rewrite this as x plus x to the negative 1, x squared plus 3. So the derivative of this times the second. So therefore, f prime equals 1 minus x to the negative 2 times x squared plus 3 plus the first times the derivative of the second, so derivative of this, which is just 2x. So now I'm going to multiply these two, so that gives me x squared plus 3. X to the negative 2 times x squared is just 1, so I'm just left with negative 1 minus 3x to the negative 2. Plus I'm going to multiply these two, gives me 2x squared plus 2. So now I have f prime of x. I collecting like terms, I get 3x squared. So those two cancel. This is 3 minus 1 plus 2, so that is 4. Minus 3x to the negative 2. And if I wanted to, I could get some common denominators here. I'm going to rewrite this as 3x squared. So therefore, I'm going to have it so everybody's over x squared. So I'm going to multiply this by x squared over x squared, and this by x squared over x squared. So I get f prime of x equals 3x to the fourth plus 4x squared minus 3 all over x squared. Either one of these answers is acceptable. Okay.